All right, saliva, mouth. 800 to 1,500 mLs of saliva produced daily. All right, stop and think about that. That's a lot of spit, right? Now, where does it come from? Parotid glands, submandibular glands, sublingual glands. So we have three pairs of glands, right? Parotids are in the cheek. Submandibular is under the jaw. Sublingual is up under the tongue. Saliva, in addition to the water, what makes saliva, what gives it its properties, is mucin, right? So mucin is a protein that's released, turns water into the slimy stuff that is saliva. Now, in addition, saliva also contains an alpha amylase called talin, P-T-Y-A-L-I-N. Talin is the first digestive enzyme that foodstuffs encounter as we eat. Okay, and amylase is a starch digester. Okay, so you can actually see talin in action if you take like a cracker and put it in your mouth and don't chew. It will eventually dissolve and disappear. Well, where did it go? It got digested by talin, right? So you absorb the disaccharides out of the starches instead. So those are the two primary components. Secretion takes place in two phases. There's a primary phase and a secondary phase. So if we look at a salivary gland, we have ductal structures that are long and thin, and then we have glandular structures at the end that look like trees. Okay? The primary secretion is happening in the tree-like glandular structure. So we're getting our talin, our mucus, and then our water, all of which combine to form saliva. Then the secondary secretion happens in the ducts themselves, and this modifies the primary secretion into the final saliva that will come into the mouth. So what's different? Sodium is reabsorbed in exchange for potassium. So that means saliva has a higher potassium level and a lower sodium level because of that. And then chloride is reabsorbed in exchange for bicarbonate. So the amount of chloride in the saliva decreases, the amount of bicarbonate increases. Now, this last bit is an active and important part of our oral health. Okay, saliva contains bicarbonate. Bicarbonate neutralizes acid. Bacteria that live in our mouths take uneaten food things and make acid out of them. Okay? So saliva is anti-cavity, right? Like tooth cavity. Because the bicarbonate neutralizes the acids that the bacteria produce. It's those acids that eat away the enamel and cause decay, right? So it means that if a patient has a problem with their salivary system, if they don't make saliva properly, they're going to have terrible tooth decay, okay, because they don't have this bicarbonate. So now, you can get tooth decay anyway, but the bicarbonate really dramatically helps to improve how long our teeth live. All right, so salivation is regulated by the brainstem, called an area called the salivatory nuclei. So superior and inferior salivatory nuclei. And then the path out of that nuclei is the tractus solitarius. And that's going to innervate the submandibular ganglion, which innervates the submandibular gland, the otic ganglion, which innervates the parotid gland, and then the sublingual gland shares the ganglion with the submandibular gland. The anatomy here is complex, and this isn't an anatomy class, but when you get to the head in anatomy, this bit where the facial nerve and the tractus solitarius share a path, you're going to hear all about that in the head, right? So it's just kind of a weird anatomic spot where the facial nerve, controlling the muscles of facial expression, passes through the same fiber as the salivary outflow, right? Now, the inputs into this system, top down, the brain matters here. Like if you know there's really great food arriving soon, well, you're going to start making saliva, right? Even though there's no stimulation. Now, once you start to eat, the tongue is going to detect the taste stimuli. It feeds into the salivatory nuclei, and then the output is more salivation. So when you start to eat, saliva is produced more strongly, right? So saliva production can increase dramatically. Baseline when we're not eating to 20 times over that when we are eating, depending on the food that we're eating and that kind of stuff, right? So facial nerve, glossopharyngeal nerve, and the chorda tympani all provide that innervation to the salivatory ganglia through that sort of complex anatomy. This is all happening, this whole bit is happening in the temporal bone, right? So these are passing through foramina in the skull.